Supplying a 200 amp main breaker panel with a 100 amp circuit is acceptable if the connected load is under 100 amps. The main breaker's primary function is to protect the incoming wires connected to it. The critical factor is ensuring that the wires connected to the main breaker are adequately sized to handle the total anticipated load and that the load remains within the ampacity rating of the installed breaker. The breaker serves to safeguard the wiring, not the load itself. It's a common misconception to think of the breaker as directly protecting the devices or equipment connected to the circuit. Its primary role is to prevent overcurrent situations in the wiring, which could lead to overheating and potentially a fire. Given that the connected load remains under 100 amps, a 100 amp circuit is sufficient to supply the necessary power. The presence of a 200 amp main breaker, while perhaps not strictly necessary for the current load, doesn't present a problem. It essentially provides an extra layer of protection for the incoming wires, ensuring that they are protected against overcurrents up to 200 amps. However, it is crucial to ensure that the wiring connected to the 200 amp breaker is appropriately sized to handle a potential 200 amp load, even if the actual load is significantly less. This is a fundamental principle of electrical safety and is outlined in the National Electrical Code, or NEC. The NEC provides detailed guidelines on wire sizing based on ampacity, which is the current carrying capacity of a conductor. The ampacity of a wire is determined by factors such as its material, size, insulation type, and installation conditions. For instance, NEC Table 310.15b16 provides ampacity ratings for various types of insulated conductors based on their size and temperature rating. When selecting wiring for a particular circuit, it's essential to consult this table and choose a wire size that has an ampacity rating equal to or greater than the overcurrent protection device, such as a circuit breaker. This ensures that the wiring can safely handle the amount of current that the breaker is designed to allow. In the described scenario, even though the connected load is only drawing under 100 amps, the wiring connected to the 200 amp main breaker should still be sized to handle 200 amps according to the NEC. This is because the breaker is designed to trip at 200 amps, and if the wiring were smaller, it could overheat and potentially cause a fire before the breaker trips. Furthermore, it's important to consider any potential future expansion of the load. If there's a possibility that the connected load will increase in the future, it's wise to size the wiring and breaker accordingly. This can save time and money in the long run by avoiding the need to upgrade the wiring later on. In addition to wire sizing, other important considerations include the type of wiring used, the method of installation, and the environmental conditions. Different types of wiring have different ampacity ratings, and the method of installation can also affect the ampacity. For example, wiring that is installed in conduit may have a lower ampacity rating than wiring that is installed in free air. Environmental conditions such as temperature can also affect the ampacity of wiring. High temperatures can reduce the ampacity of wiring, so it's important to take this into account when selecting wiring for a particular application. In the case of the gas station control panel, it's important to ensure that all wiring and equipment are suitable for use in a hazardous location. Gas stations are typically classified as hazardous locations due to the presence of flammable vapors. The NEC has specific requirements for electrical equipment and wiring that is used in hazardous locations. These requirements are designed to prevent explosions and fires. For example, electrical equipment that is used in a hazardous location must be explosion-proof or intrinsically safe. Explosion-proof equipment is designed to contain any internal explosion, preventing it from igniting the surrounding atmosphere. Intrinsically safe equipment is designed to limit the amount of energy that is released, preventing it from igniting flammable vapors. In addition to explosion-proof or intrinsically safe equipment, wiring that is used in a hazardous location must be installed in a way that prevents the ingress of flammable vapors. This can be achieved by using sealed conduit or by using special types of wiring that are designed for use in hazardous locations. It's also important to ensure that all electrical connections are tight and secure, as loose connections can create heat and potentially ignite flammable vapors. The installation of the gas station control panel should be performed by a qualified electrician who is familiar with the NEC requirements for hazardous locations. The electrician should carefully inspect the installation to ensure that all wiring and equipment are installed correctly and that all safety precautions are followed. In summary, supplying a 200 amp main breaker panel with a 100 amp circuit is acceptable as long as the connected load is under 100 amps and the wiring is properly sized to handle the potential 200 amp load. The main breaker is there to protect the incoming wires, not the load. It is critical to adhere to all relevant electrical codes and safety standards, particularly when dealing with hazardous locations such as gas stations. This includes selecting the correct type of wiring, ensuring proper installation techniques, and using appropriate explosion-proof or intrinsically safe equipment. Firstly, ensure the 100 amp circuit breaker is properly sized for the existing wiring. Secondly, the wiring must be capable of handling the anticipated continuous load with an appropriate safety margin. Thirdly, consider the potential for future load increases and size the wiring accordingly. Fourthly, verify that all components and wiring are rated for the specific environmental conditions, including temperature and humidity. Fifthly, for gas stations, strict adherence to hazardous location requirements in the NEC is crucial. Sixthly, grounding and bonding practices must meet code requirements to prevent electrical hazards. Seventhly, all connections should be torqued to the manufacturer's specifications to ensure secure and reliable connections. Eighthly, conduct a thorough inspection after installation to verify compliance with all applicable codes and standards. Ninthly, document all aspects of the installation, including wire sizes, breaker ratings, and grounding configurations for future reference. Tenthly, provide training to personnel who will be operating or maintaining the equipment on the proper safety procedures and emergency shutdown protocols. Considering these points will help ensure a safe and compliant electrical installation. It's also important to note that the NEC is updated every 3 years, so it's crucial to stay current with the latest edition. The NEC is a complex document, and it's not always easy to understand. If you have any questions about the NEC, it's best to consult with a qualified electrician. An electrician can help you understand the code and ensure that your electrical installation is safe and compliant. The electrician should possess a thorough understanding of electrical principles, wiring methods, and safety codes. They should also have the ability to read and interpret electrical blueprints and schematics. Furthermore, the electrician should be proficient in using various electrical testing equipment, such as multimeters, ammeters, and ohmmeters. This equipment is used to measure voltage, current, and resistance, which are essential for troubleshooting electrical problems. In addition to technical skills, an electrician should also have excellent communication skills. They should be able to clearly explain electrical concepts to customers and co-workers. They should also be able to work effectively as part of a team. The installation of electrical systems is a complex and potentially dangerous task. It's important to hire a qualified electrician who has the knowledge, skills, and experience to do the job safely and correctly. Working with electricity can be dangerous, and it's important to take precautions to avoid electrical shock. Always turn off the power before working on any electrical equipment. Use insulated tools and wear appropriate safety gear, such as rubber gloves and safety glasses. If you are not comfortable working with electricity, it's best to hire a qualified electrician. Electricity is a powerful force, and it should be treated with respect. By following these safety precautions, you can help prevent electrical accidents. The 200 amp main breaker in the panel acts as an overcurrent protection device. It is designed to trip and interrupt the flow of electricity if the current exceeds 200 amps. This protects the wiring and equipment connected to the panel from overheating and potential damage. The 100 amp circuit that feeds the panel is also protected by a 100 amp circuit breaker at the source. This breaker will trip if the current exceeds 100 amps, protecting the wiring from the source to the panel. The combination of the 200 amp main breaker and the 100 amp circuit breaker provides 2 levels of overcurrent protection for the electrical system. The 100 amp breaker protects the wiring from the source to the panel, while the 200 amp breaker protects the wiring and equipment connected to the panel. In this scenario, the connected load is under 100 amps, which means that the 100 amp circuit breaker is sufficient to handle the load. The 200 amp main breaker provides additional protection, but it is not necessary for the connected load. However, it is important to ensure that the wiring connected to the 200 amp main breaker is sized to handle a potential 200 amp load. This is because the breaker is designed to trip at 200 amps, and if the wiring was smaller, it could overheat and potentially cause a fire before the breaker trips. The selection of the appropriate wire size is crucial for ensuring the safety and reliability of the electrical system. The wire size should be based on the ampacity of the conductor, which is the maximum amount of current that the conductor can safely carry. The ampacity of a conductor is determined by factors such as its material, size, insulation type, and installation conditions. The NEC provides tables that list the ampacity ratings for various types of conductors based on their size and temperature rating. When selecting wiring for a particular circuit, it's essential to consult these tables and choose a wire size that has an ampacity rating equal to or greater than the overcurrent protection device. The installation of the wiring should be performed by a qualified electrician who is familiar with the NEC requirements for wiring methods. The electrician should carefully inspect the installation to ensure that all wiring is installed correctly and that all safety precautions are followed. In summary, supplying a 200 amp main breaker panel with a 100 amp circuit is acceptable as long as the connected load is under 100 amps and the wiring is properly sized to handle the potential 200 amp load. The main breaker is there to protect the incoming wires, not the load. It is critical to adhere to all relevant electrical codes and safety standards, particularly when dealing with hazardous locations such as gas stations.